Hello everyone, this is Devabrata and welcome everyone to our channel Schrodinger's Cat. So basically today we will discuss the more important topic for the IIT JAM, JEST, NET, GATE and TIFR aspirants, the electromagnetic wave under the chapters Electromagnetic Theory, and today we will discuss the 5 topic on each Poynting theorem, waves in one-dimensional sinusoidal waves, the wave equation, terminology, complex notation, polarization, EM wave in vacuum, the wave equation for electric field and magnetic field, monochromatic plane waves, energy and momentum in EM waves in matter, EM waves in conductor, and the total number of questions are coming in the entrance exam like IIT JAM. Basically for JAM exam we have 9 number of questions. For JEST 5 to 6 questions are coming. For TIFR this is also TIFR little bit less, just 2 or just 5, and for CSIR NET we have just 8 questions, and GATE 7 to 8 questions are coming from EMT topic. And today we will discuss the important topic electromagnetic wave. Here 1 or 2 questions are coming this part. And one notice is that since we are looking from the exam point of view, so we will cover the chapters by solving problems called chapter summary, and after that when we will get time we just elaborately do the theory class to clear the concepts. So go ahead, our topics. First one is Poynting theorem. This is basically the work energy theorem, and just write it for the formula that the U EM electromagnetic half integration epsilon naught square plus b square by mu naught d tau, and we have the epsilon naught by 2 integration square d tau, and for magnetic Wm 1 by 2 mu naught integration b square d tau. And our Poynting theorem mathematically express that dw dt is equal to minus ddt of integration over volume half epsilon naught square plus 1 by mu naught b square d tau minus 1 by mu naught surface integral of E cross B dA elementary surface area. This is our Poynting theorem, and Poynting vector states that the S is formally written as 1 by mu naught E cross B, final outcome. And after we just go through some terminology here, that waves in one dimensional. So basically we have that the FZT is written as A cos A Z minus Vt plus delta phase difference, and phase constant the delta is in the range of 0 less than equal to delta less than equal to 2 pi, and we have know the formula that lambda 2 pi by k wave number, t 2 pi by k nu, and nu is basically 1 by t nu by lambda, and omega 2 pi nu k nu. This is wave number, time period, frequency and angular frequency. So our next discussion would be EM waves in vacuum. So basically we have just write here that the wave equation for E and B, basically del dot E equal to 0, divergence of B is equal to 0, curl of E is minus del B del T, and the last one, curl B is equal to epsilon naught mu naught del E del T. And for free space, rho must be 0, J must be 0, and the wave equation would like to have seen that del square E equal to mu naught epsilon naught del square E by del T square, and del square B is equal to mu naught epsilon naught del square B by del T square. So basically we have the functions here that del square F equal to 1 by V del square F del T square, and V must be 1 by root over mu naught epsilon naught is equal to C. So velocity of light in free space. And for the monochromatic plane wave, this is formula for exam purposes, that E ZT E naught exponential I kz minus omega t, and BZT B naught exponential I kz minus omega t. And the important thing that we have to convert E to B, that would become B naught k by omega z cross E naught, and basically B naught k by omega E naught is equal to 1 by C E naught, and the another one, B to E transform B RT should be 1 by C k cross E, and ERT, this is formally minus C k cross B, and N dot K must be 0. So that the energy and momentum in EM wave, the momentum density stored in the field, that P momentum density stored in this field 1 by C square S, and S be the Poynting vector. For monochromatic plane wave, we get monochromatic plane wave 1 by C uz. U is basically the energy density written in the form that the U average half epsilon naught square, S average half C epsilon naught square Z, P average must be 1 by 2C epsilon naught square Z, and I intensity is average of Poynting vector, basically half C epsilon naught. This formula is, keep in mind, very important, E naught square intensity, and radiation pressure P I by C, and for perfect reflector P should be 2I by C. One is going one direction, another is other directions. Another part, electromagnetic waves in the matter. For that we consider here rho f and Jf tends to 0, and we have the Maxwell's equation here is in the form divergence D 0, divergence B 0, here curl E minus del B del T, curl H del D del T, and V 1 by root over epsilon naught mu equal to C by N, wherein index root over epsilon mu by epsilon naught mu r, and N should be root over of epsilon r, index of reflection where mu r is equal to 1 for non-magnetic material. Non-magnetic materials, for non-magnetic materials. And the last one, that the EMF in the conductors. So basically here that rho final T should be the exponential minus sigma by epsilon T rho f0. This equation is rho f at time t to rho f at 0 t0 tau epsilon by sigma, where, and we have here the Maxwell's equation that divergence E should be 0, divergence B should be 0, curl E minus del B del T, and the curl B mu epsilon del E del T plus mu sigma E. This is our Maxwell's equation here. And one important thing, that skin depth, basically EMF passing through the conductor, so here into k square must be mu epsilon omega square plus I mu sigma omega, and k be the one real part and one be the imaginary part, where lambda 2 pi by k, v be the omega by k, and a be the ck by omega. Short formula. And the one important terminology, that the skin depth B should be 1 by k. This basically k rest 1 by this part, inverse of. And For pore conductor, we would like to be the equations or conductor where sigma less than omega epsilon, K must be the sigma by 2. In JEST exam, the formula must is come is one type of exam questions. So basically this is independent of frequency, and the final result omega root over epsilon mu by 2 root over 1 plus sigma by epsilon omega whole square minus 1 to the power half, where omega 2 pi f and sigma 1 by rho. And for the another one, for the good conductor where sigma greater omega epsilon, this basically K equal to K dashed root over omega mu sigma by 2. This basically skin depth D equal to reciprocal of K. This formula very important, 2 by omega mu sigma, and it should be written as 1 by pi f mu sigma, So here we just conclude our theoretical formalization with concepts. Now we just go ahead our question discussion sessions. So basically we have the first questions. Is in the net 2017. An electromagnetic wave is traveling in free space of permittivity epsilon naught with electric field E vector is equal to K naught cos Q x minus Ct. The average power per unit area crossing plane parallel to 4x plus 3y equal to 0 will be. We should find the average power. Basically the intensity. We just write the equation that average of Poynting vector into direction. So we have a line. So we have basically a line. This is our 0. We have this line 4x plus 3y, and this is basically direction, and the direction, and this is another one, and here this is K, this is B, and another one is E. This is 3 and 4, this line, and this direction is n cap, and this should be 90 degree, and this angle is alpha, and this is 90 minus alpha. So basically we just try to solve here that 4x plus 3y is equal to 0. We should give the equation of straight line that x by 3 y by 4 is equal to 3. X by 3 plus y by 4 is equal to 0. Basically the x by a plus y by b equal to 1 straight line, and this E is given K E naught cos Q x minus ct. So we should convert e to b, and we just previously discussed and write the equations for converting. So we just put these equations that b rt is basically 1 by c k cross e. This is our equation, and k is in the x cap, and this is y cap, and this is z cap. You just cross here and get the result minus e naught by c cos q multiply is within the bracket qx minus qct and y, and we have the formula of Poynting vector, that s, that 1 by mu naught e cross b. So basically 1 by mu naught, e means e naught by c cos square theta x cap. So basically we get here the expectation of, or average, basically average of Poynting vector is e naught square by 2 mu naught c x cap, and our final result that we should find the I, that should be the average of Poynting vector into n. We just put the value e naught square by 2 mu naught c, and cos n cap is basically, this is our n cap. So cos 90 minus alpha, just put the geometry here, and you will get this 90 minus alpha and e naught square by 2 mu naught c sin alpha, and this is basically 2 by 5 c epsilon naught e naught square, and with the triangle we have get this value tan alpha equal to 4 by 3, and from here we get sin alpha equal to 4 by 5, put here, and after we get the value I approximately 0.4 c epsilon naught e naught square, basically half c epsilon naught e naught square. So the average power, this would be the answer, half c epsilon naught e naught square. So go ahead, our next problems coming in JEST 2017 is basically a plane electromagnetic wave propagating in air with E 8i cap 6j cap 5k cap exponential I omega t plus 3x minus 4y is incident on a perfectly conducting slab positioned at x equal to 0. So basically we have to find the field reflected wave. So we have to find the equation of reflected wave equation. So basically, given that E is 8i 6j 5k exponential of I omega t plus cx minus 4y, and given the value of n cap be this one 8i plus 6j, I just write here I, but this would be I cap plus 5k, and k, the propagation vector, would be ci minus 4j according to the questions. So we check that k dot n. So basically you just check k dot n for the options A, B and C, D. We just randomly check into the C option. So for C option k dot n, we just randomly check C, D, B, A. K dot n is equal to minus 3i minus 4j dot minus 8i plus 6j minus 5k. This is basically 24 minus 24 equal to 0. And if we check in the option D, we just get here minus 3i minus 4j dot minus 8i minus 6j minus 5. This is basically 24 plus 24 equal to 48, that not equal to 0. So you should check that k plus k dot n cap must be 0. So C option is 0, so C would be the answer. Go ahead, our next problem coming in TIFR 2017. An electromagnetic wave in free space is described by EXYZT is equal to z cap E naught half kx minus root 3 ky minus 2 omega t. The Poynting vector associated with this wave is along the direction. We have to find the Poynting vector of the direction of the Poynting vector. Basically, we have to find the n cap, that given by the questions the phase, because phase is the associated with the Poynting vector, basically k by 2 here, half should be inside k by 2x minus root 3k by 2 y minus omega t. After on, that k dot r should be, r must be xi yj zk and k by 2i minus root 3k by 2j dot r. Basically we would get k by 2i minus root 3k by 2j, and unit vector is direction of propagation. Unit vector is basically the direction of propagation, and it would become the Poynting vector direction. Basically n cap is k vector by mod of k vector, basically the unit vector. So half, we just find here the value half I root 3 by 2j, k must be cancelled with numerator denominator, half should be common here, I minus root 3j, and this would be right in the xyz form, Cartesian form, that c I must be, c is the constant, half x cap minus root 3 y cap. So our answer would be the x minus root 3 y, x minus root 3 y. So go through our next problem coming in IIT JAM 2018. Basically consider an electromagnetic plane waves where E is equal to E naught I plus Bj cos 2 pi by lambda Ct minus x minus root 3y, where lambda is wavelength and c is the speed of light, b is the constant, the value of the b. Constant value should we find? We have given the electromagnetic equation. We just write this equation in the standard form, E equal to E naught n cap cos omega t minus k dot r. In the standard form we just write here, and compare this equation 1 and 2. We get n cap is I plus bj, and k must be 2 pi by lambda I minus root 3j, and as k dot n the condition must hold in this questions. K dot n 0 we just put here, get 2 pi by lambda. K dot n, this is n and this is k, so multiply we get 1 minus b root 3 is equal to 0 basically, or b would be the 1 by root 3, basically 0.577. This would be the answer. This is coming in the NAT section in IIT JAM, and you should write here the numeric value 0.577. So go ahead, our last questions. We just put here the questions in IIT JAM, JEST, NET, GATE and TIFR, 5 questions, standard question, and if you try to solve this question with conceptual, and you should solve the another questions coming through this entrance exam like this. So basically we have given the question is in the form of the electric field of an electromagnetic wave in vacuum is given by E is equal to E naught cos 3y plus 4z minus 1.5 into 10 to the power 90x. The wave is reflected from the z equal to 0 surface. This is very important, z equal to 0 surface, and if the pressure exerted on the surface is alpha epsilon E naught square, the value of alpha, this coming get NAT type question, and NAT type is very curious, and be careful for solving this question. So basically we have by the question k, the Poynting vector is that 3y plus 4z, 3y plus 4z, and tangent of theta basically ky by kz, 3 by 4. This component ky 3 and kz 4. As z equal to 0 we consider here, and from here tan theta equal to 3 by 4 we get the cos theta value 4 by 5, and the formula we just write after solving this problem that P exerted pressure 2 I by C cos theta, put the value 2 half epsilon naught E square into cos theta 4 by 5. You just calculate numeric to cancel 5 to 0.8 epsilon naught E square. So here compare this alpha epsilon naught E square, alpha epsilon naught is wrong, alpha epsilon E naught square, we just get the value of alpha 0.8. So 0.8 would be your answer. So we have solved the 5 standards questions coming in NET, JEST, TIFR, IIT JAM and GATE. So I usually give homework for the better understanding. Just we have solved the 5 questions, so homework for you, these questions 1, 2, 3, 4, 5 for practice, and standard questions from the entrance exams. So basically first one is a monochromatic plane wave in free space with electric field amplified of 1 per voltmeter is normally incident on the fully reflecting mirror, and the pressure exerted of the mirror is the pressure exerted of the mirror. We just solved this type of question. You just pause this video and take a screenshot of this page and try to solve these 5 questions in standards, JAM, JEST, NET, GATE and TIFR previous year question, and after solving just mail me in the given ID. I just see after this taking screenshots, and on 3 each NAT type questions and 2 each MCQ. The electric field of an electromagnetic wave EZT is equal to E naught cos kz plus omega ti plus 2 E naught sin kz plus omega tj, where omega and k are the positive constant. This represents a linear polarized with z direction positive, circular polarized, elliptical polarized, unpolarized. And this polarized part we are when we will just consider the discuss of the polarization in light, we just give the and write this formula and the concepts of linearly polarized, circularly and elliptically or unpolarized, the condition of H. This is basically important, and you just take screenshot of this page and the 5 questions. Our last but not the least, the contact that solve this homework. And if anyone needs these files like the study material of my YouTube lecture, just mail without any hesitation to the ID catschrodingers1935@gmail.com. So finally conclude with that, thank you very much, stay well and happy, goodbye, take care.